Dear children, welcome to lecture 9 of chapter 1, Maths, Number Systems. Today we are going to study rationalization. Now, what is this rationalization? Rationalization is conversion of irrational denominator to rational denominator of an irrational number is called rationalization. Now this is something new for you, and I know you'll take some time to understand it. So let me explain one example first, then we'll come back to the definition. Okay, fine. Let's take an example of an irrational number 1 upon root 2. Now as we can see that this number 1 upon root 2 is an irrational number because when we'll find out square root of 2, it's a prime number, that would be non-terminating and non-repeating. So basically this root 2 is an irrational number. Okay, so and we also know that every number has a standard form to write. Like for example, just assume we are doing some calculation and at the end we get an answer as 5 upon 5. Do we leave our answer here only? Do we leave our answer here? No. What we do? 5 divided by 5 is 1. We leave our answer here. Why? Why don't we leave our answer 5 by 5 or 2 by 2 or 7 by 7? Why do we leave our answer at 1? Why do we finish at 1? Because this is a standard form to write an answer. We cannot leave it like this because we know that 5 divided by 5 is 1 and this is the reduced form. So the point which I'm trying to make you clear is that there is a standard way of writing anything. Similar standard way of writing a rational number which you have already done in class 8 is whenever, suppose in any type of calculation you get your answer as 6 by minus 7. Do you leave your answer like this? No. What you do is you first make this negative denominator positive by multiplying the numerator and denominator by minus 1 so that you get minus 6 upon 7 and then you leave it as your final answer. Why? Because this is the standard way of writing rational number, that denominator should be positive. Okay, similarly we have a standard way of writing an irrational number, and what is that way? That our denominator should be a rational number. Our denominator should be a rational number. But pay attention here, this is an irrational number. So how we will make this irrational number to how we'll change this to rational number? Now one more point I want to make you clear is that we are not going to change irrational number to rational number. No, this we can't do. Okay, so we are not going to do this. हम ये नहीं कर रहे हैं. We are not changing it. We cannot convert an irrational number to rational number. No, we can't. Right? What we are doing is we are just changing the denominator. We are changing irrational denominator to rational denominator. This is what we are doing. Irrational denominator to rational denominator. We are not changing number because we can't change the number. So now the question arises, how do we change an irrational denominator to rational number? Now pay attention here, our number was 1 upon root 2. Now if I multiply this number by root 2 in both numerator as well as in denominator, what will happen? See, basically what I'm doing, I'm multiplying by 1. I'm not changing it. I'm not changing my number because root 2 by root 2 is 1 only. So basically I'm multiplying by 1. But when upon doing so, what will happen? 1 into root 2 is root 2. That is our numerator. And root 2 into root 2 will be 2. That I told you in my previous lecture, that root 2 into root 2 means root 2 ka square. And square and root will be cancelled out and you will be left with the number. Okay, so now previously your denominator was root 2, which was an irrational number, but now your denominator is 2, which is a rational number. So this whole process of changing irrational denominator to rational denominator is known as rationalization. This is known as rationalization. And the number by which we have multiplied in both numerator and denominator in this changing is called as rationalizing factor. This is called as rationalizing factor. So now come back to the definition that I have written. What is rationalization? Conversion of irrational denominator to rational denominator of an irrational number is called rationalization. And how we do this rationalization? By multiplying rationalizing factor in both numerator and denominator of an irrational number. And I'm pretty much sure now these two lines are clear to you, because if you have understood this example, now these both lines are clear to you. And you can change any irrational denominator to rational. Now I'm pretty much sure. Let's do one more example. Suppose you have an irrational number 7 upon root 15. Now this is your irrational denominator. We want to change it to the rational denominator. I told you what we have to do is we have to multiply in numerator and denominator by rationalizing factor. Now the question arises, what is that rationalizing factor and how do we know that by which number we have to multiply? Very simple. Just whatever the denominator of your irrational number is, just multiply by that in your numerator and denominator, so that your denominator gets squared and your root would get cancelled out. Okay, this is the basic reason why we are multiplying the denominator only in both numerator and denominator. So whatever is your denominator, just multiply it by your just multiply it in numerator and denominator. That will be your rationalizing factor. So here your denominator is 7 upon root 15, the denominator is root 15, so our rationalizing factor would be root 15. We will multiply it in both numerator and denominator. What we will get, 7 into root 15 is 7 root 15, and root 15 into root 15 is 15. This is irrational and this is rational. This process is called as rationalization, and this root 15 is called as rationalizing factor. Rationalizing factor. I hope this is clear to you. I have one more example by which I think this will become more clear. Okay, now the third example is 12 by 2 minus root 5. Okay, now the question arises, what would be our rationalizing factor? Now you would say that ma'am, you just told us that the number which is there in the denominator, that square root number, we should multiply it in the numerator and denominator. That would be a rationalizing factor. So here, because we have root 5 in our denominator, so we should multiply this irrational number by root 5 in both numerator and denominator. This you must be thinking. Okay, so let's do it. Whatever you are saying, you are thinking, let's do it. 12 upon 2 minus root 5 is our question, and according to this thinking, I'll multiply by root 5 in both numerator and denominator. What do we get? 12 into root 5, 12 root 5, and 2 minus root 5 into root 5 would be, first I'll multiply root 5 by 2 and then I'll multiply root 5 by root 5. So 2 into root 5 is 2 root 5 minus root 5 into root 5 is 5. But our denominator is not rational. Our denominator is still irrational. So that means this is incorrect approach. This is totally incorrect approach. Now the question arises, then what should be the correct approach? Now actually this is what? This is your binomial. Binomial means there are two terms in your denominator. Earlier the examples 1 upon root 2, 7 upon root 15, they were having only one term. due to which we got our rationalizing factor very easily. This was the rationalizing factor, this was the rationalizing factor, but here this is binomial. We have two terms. So now we will make use of identity, which I told you in my previous lecture. What is that? This is, if suppose this is a minus b, so I'll multiply it by a plus b, because a minus b into a plus b is equal to a square minus b square, and once I get the square of the root would be cancelled out. This is what we'll do. We will make use of identity a minus b into a plus b, that is equal to a square minus b square. Here in this case our a is 2 and b is root 5. So already we have a minus b. So by what expression we have to multiply? We have to multiply by a plus b. So what would be a plus b? Since our a is 2 and b is root 5, so a plus b would be 2 plus root 5. So we will multiply our irrational number by root 2 plus root 5. Just see, 12 upon 2 minus root 5, we will multiply it by 2 plus root 5, 2 plus root 5. What will happen? 12 into 2 plus root 5 I have written as such. Now this is a minus b into a plus b, and we know that a minus b into a plus b is a square minus b square. 2 square minus root 5 ka square. What would be square of 2? 4. And what would be square of root 5? Square and root would be cancelled out, only 5 would be left. 4 minus 5 is minus 1. So the answer is minus 1. So basically our denominator which we will get upon solving is minus 1. And I told you that we don't keep our denominators negative, so I have multiplied it by minus 1 in both numerator and denominator, so that we get minus 12 into 2 plus root 5 upon 1. Right? Now our denominator is rational. So our rationalization is complete. And what is the rationalizing factor in this case? 2 plus root 5 is our rationalizing factor. So children, remember, if you have a monomial simple single denominator, then that denominator will be the rationalizing factor. उसी से ऊपर नीचे multiply करेंगे. But in case if you have binomial, two terms in your denominator, then whatever your denominator is, just change the sign. That would be your rationalizing factor. Like suppose here 2 minus root 5 is there, so our rationalizing factor would be 2 plus root 5. If suppose it would have been 6 plus root 8, suppose, then the rationalizing factor would be 6 minus root 8. Why? Because at the end we are using the identity a minus b into a plus b, that is equal to a square minus b square. Okay, one more thing why we do this rationalization is because when we had our irrational number 1 upon root 2, we are not clear with the what amount is this, how much is this number. But when we rationalized it, we got root 2 by 2, that means half of root 2. The number is much more clear now. Earlier it was not clear what is the amount and how much is the number, but now it's clear that the number says that it is half of root 2. Similarly, in the second question, here we are not clear with the number, but here we are clear. This is 7 by 15th part of root 15. Okay, so rationalization gives us the standard form, as well as we are able to understand the number more accurately. Okay, so children, I have some questions for you for rationalization. These are the NCERT exercise 1.5 questions, and please do them in your maths notebook using the information which I provided you in this lecture. I hope you all will be able to do this. The questions are exercise 1.5 question number 5, rationalize the denominators of the following. We'll discuss the rationalizing factors. Okay, the first one is 1 upon root 7. So as you can see, what will be the rationalizing factor? Root 7 only. We'll multiply it by root 7 in both numerator and denominator. Then 1 upon root 7 minus root 6. Now what will be the rationalizing factor? Because it is a binomial, so we will just change the sign. Root 7 plus root 6 would be the rationalizing factor. So we'll multiply it by root 7 plus root 6 in both numerator and denominator. Next, 1 upon root 5 plus root 2. So now here what will be the rationalizing factor? Just change the sign, root 5 minus root 2. We'll multiply this irrational number by rationalizing factor this in both numerator as well as in denominator. Next, 1 upon root 7 minus 2, what would be the rationalizing factor? Root 7 plus 2 in both numerator as well as in denominator. Next, 5 upon root 3 minus root 5, what would be the rationalizing factor? Root 3 plus root 5 in both numerator as well as in denominator. And the last, 1 upon 2 plus root 3, the rationalizing factor would be 2 minus root 3. And then use the identity a minus b. A plus b is equal to a square minus b square. So I hope this rationalizing is clear to you. After rationalization and the next topic, exercise 1.6, I'll provide you some extra questions which generally come in exam. So children, this is one of the important topic of this chapter, rationalization, and I want everyone to practice these questions. You should get master in rationalization, then only you will be able to solve those higher order questions, okay, higher order thinking questions. So please, all the best, do your work, and stay home, stay safe. Thank you.